Right, Brill. Morning, year 13. Thanks to all of you to coming on. I know it's hard getting out of bed and getting motivated, right? But it's important, and we're going to see it through. There's not a lot left for me and Mr. Bounds to cover now, right? I got one big topic in mechanics to do, vectors, but pretty much the pure is almost done. And of course, all the stats is done, which is great. There's only the 2nd of February, which would give us loads of time to do revision for the exams that are not happening. However, your engagement and efforts and handing in of work is still going to be absolutely paramount to your centre-determined grade. So keep up, right, the very, very good work. Try and keep motivated. I know how difficult it is. So I want to revisit partial fractions, which is the first topic you did with me back goodness knows when. And what we never did at the time was look at the second part of the question, which then invites you to differentiate or integrate your 3 or sometimes 2 fractions. Because at the time, you hadn't gone through the integration with Boundsy, but obviously now you have. So we're going to see it through, right? So in a nutshell, your partial fractions, you're going to set it up as 3 separate fractions, A over something, B over something, and C over something. It's usually one squared term, one linear term, and then one of each next to each other. You substitute in values of x, and you pick the first 2 values you pick will make the bracket 0, so they disappear. I hope this will all come flooding back to you. And usually, if we haven't used x equals 0, we chuck in x equals 0 for the third one because that makes it easy. And if you have to integrate at the end, which they change it every year. 1 year is integrate, 1 year is differentiate. Don't forget to look for logs, which you now know how to do. And you must put that plus c on the end if it's an indefinite integral, right? I double checked last year's marking scheme just before this lesson, and you would lose a mark if you didn't put that plus c on the end, right? So that is vital. So how are we going to do it today? I'll go through the first couple. Obviously, you can scribble along at the same time. Hiya, Jacob, mate. Sorry, I didn't see you was in there. Hope you're well. I'll try and refresh you on how we solve the partial fractions. I'll do a differentiation one. I'll do an integration one. Then I'll ask you to do, 3 or 4 on your own. So I'll pause, give you 4 or 5 minutes, and then go through the solutions, right? So let's have a look at this first one. If you remember, when I introduced this topic to you, I do like to have the squared term on the right. So that varies as well from year to year. They put the squared term on the left and on the right. I always like it on the right because that's my routine that I've learned and practiced, and I always encourage you to do the same. So we don't need to, we can cut straight to the chase, right? We don't have to write out all the reasons why the x minus 2 all squared term comes up to the left, right? We've done all that theory. We just need to know the routine. So I'm going to keep that numerator, 8 minus x squared, and I'm going to equate that to a with the squared term next to it, plus b with one of each next to it, and then plus c with the linear term next to it. So hopefully that rings some bells. And the reason that's come from, I should have wrote it down, I guess, because that'll be a over x, plus b over x minus 2 plus c over x minus 2 squared. So when we do finish the question and we work out the values of a, b, and c, that is what they will go over. Okay, right. So let's pick this one first. Obviously, if I put x equal to 2, this is going to be 0. So there's my first pick. So let the examiner know, let x equal 2. So 8 minus 2 is 6. 6 minus 2 squared, 6 minus 4 is 2. So I've got 2 there. 2 minus 2 is 0. That goes. 2 minus 2 is 0. That goes. So I'm just left with 2c. So c must be 1. All right, I'm assuming that's okay so far. Now let's check in x equals 0, because that'll disappear and that'll disappear. So let x equals 0. 8 take away nothing is 8. That goes, that goes. 0 take away 2 is minus 2. Minus 2 squared is 4. So 8 equals 4a. So a equals 2. I'm sure you all agree with that. Now, normally, we would have x equals 0 as our third number going in, but obviously we've already used it. So you could use any number. You could use the square root of pi if you want. But I would go for something a bit easier. So I'm going to go for x equal 1. 8 take away 1, take away another 1 is 6. 1 take away 2 is minus 1. Minus 1 squared is 1. So that's 1a. 1, 2 is 2. 1 take away 2 is minus 1 times 1 is minus 1. So that's minus b. And then 1c, and c is 1. 1, 1 is 1. So that's what I've got from chucking in x equals 1. 2 plus 1 is 3. 3 take away what is 6. So b is minus 3. All right, double check that with me. 2 minus minus 3 is 5, plus 1 is 6. So I think that's correct. I'm pretty sure that's correct. So rewrite out the original fractions using these values of a, b, and c. So I've got 2 over x minus, put the minus there, don't put plus and then minus 3. I'll be daft. If there's a minus, put the minus there, minus 3 over x minus 2 plus 1 over x minus 2 squared. So that's the partial fraction bit done, and that was worth 4 marks, right? So that's just routine and practicing, careful with your minuses, etc., etc. And that is f of x, okay? Now they've asked us to find f dash of 1. So f dash means differentiate it. And then of 1 means once you've differentiated, chuck all your x values, substitute your x for the value of 1, work it all out, and come up with an actual numerical answer. So this is how I would differentiate this. I would rewrite them first of all as 2x to the minus 1 minus 3 brackets x minus 2 to the minus 1 plus x to the minus 2 to the minus 2. So what I've done there is I've eliminated the fraction part of it by using the negative indices. This is just how I do it, okay? Because now to differentiate, you bring the power down and reduce the power by 1. So if I differentiate this, bring the power down, 2 times minus 1 is minus 2. Reduce that power by 1, goes to 2x to the minus 2. Similarly for this, power down, so I've got minus 1 times minus 3, which is plus 3, and that then goes to minus 2. Now don't forget, if there was a coefficient in front of that x, you would have to include that in the differentiation or integration part as well. They don't tend to do that, okay? And then the last one, power down, minus 2, brackets, x minus 2, reduce the power by 1 to the minus 3. So that is what we would now call f dash of x. I hope you're all still with me. And then finally, we want to substitute 1 into all of these, okay? And as much as it hurts me, I know you're all picking up the calculators right now. I refuse to do that. So f dash of 1. Right. That's minus 2 over 1 squared. So that's minus 2. That's 3 over minus 1 squared, which is 3 over 1, which is plus 3. And that's minus 2 over 1 minus 2 is minus 1. Minus 1 cubed is minus 1. It's a minus over a minus, which is a plus. So that's 2 over 1, which is 2. Minus 2 plus 2 cancel out. The answer is 3. Did anybody get that ahead of me. Is anybody ahead of the game there and got out the answer? F dash of 1 is 3. I'll take that silence as a massive yes. Any questions on that? Anybody get lost at any point? Want me to recap anything? Or are we happy to move on? Okay. Right, I'll go on to the next one then, okay? So 4 marks up to there, and then 3 marks for the differentiating. All right, next one then. Are you still there? Can someone just type something or say hello so I know my computer's working? Okay, thank you, Natasha. Right. Now here's an example of what I was on about earlier, where the squared term is on the left. And of course, it doesn't matter. You just have to swap around your A, B's, and C's. Thank you, Catherine. Right. But I like it the other way around, right? It's just my OCD. So I would have written this out if I was in an exam like this, because I don't want to give myself any opportunities to ruin my routine. So I would have written it out like this, and I would have had A over X minus 3 plus B over 1 of each plus C over X plus 2 squared. Sorry, not 1 of each, just when it comes upstairs. It's just the linear term there. I do apologize. Right, so write down the numerator, x squared plus x plus 13. This term comes up by A. 1 of each comes up by B. This one comes up over by C. That's the routine, right? So A, x plus 2 all squared plus B, 1 of each of them, plus C, x minus 3. And again, the routine now is pick values of x that are going to turn the brackets into 0. So I'm sure you'll agree we'll use x equals minus 2, and we'll use x equals positive 3. That will eliminate 2 of them, and then we'll use x equals 0 to get the third one. All right, so obviously I'm going to go through it, but hopefully you're scribbling away now, having a crack at it yourself. Once we've done that and rewritten it out as partial fractions, it's asking us then to find the definite integral of it. All right, so we'll integrate it, chuck in 7, chuck in 6, subtract those answers, and get a numerical answer. It says give your answer correct to 3 dp's, so it isn't obviously going to be a whole number. Right, so let's do it then. Let's start with the positive one. Let's chuck in x equals 3. 3 squared is 9. 9 plus 3 is 12. 12 plus 13 is 25. 3 plus 2 is 5. 5 squared is 25. That'll disappear because that's 0. That'll disappear because that's 0. That makes me feel all warm and fuzzy because A equals 1. All right? It's not often that they come out stinky like a 7th or something like that. It does happen, but it's not often. Okay, so if it comes out as a nice whole integer, happy days. So now we'll chuck in x equals minus 2. Minus 2 squared is 4. 4 take away 2 is 2. 2 plus 13 is 15. That goes because it's 0. That goes because it's 0. Minus 2 minus 3 is minus 5. So 15 is minus 5c. So C is minus 3. I'm happy with that as well. I'm going to expect at least one of them to be negative, but at least it's a whole number. So you can pick anything for the third one, but I have advised you to always go for 0 if available. So I'm just left with 13 on the left, 0, 0, 13. Right, 0 plus 2 is 2. 2 squared is 4. So I've got 4 A's, which is 4 1's, which is 4. These are both 0. So I've got minus 3 times plus 2 times b, which is minus 6b. And then 0 minus 3 is minus 3. So I've got minus 3 times c, minus 3 times minus 3 is plus 9. And on initial inspection, you might think, hang on, I've done something wrong. 4 plus 9 is 13. 13 take away 6b is 13. That doesn't feel right. It doesn't sound right. So go back through again on exam day probably and check it all. It is right, okay? So the only value for b would be 0. B has come out as 0, which is actually quite handy for us because now when we rewrite out our 3 fractions to integrate, there's only going to be 2 of them. Huzzah! So we are left with f of x equals a over x minus 3, which is 1 over x minus 3. This one has disappeared because b is 0. C is minus 3, so it's minus 3 over x plus 2 squared. Right, so now we need to integrate that. So we want the integral of that, and the limits are 7 and 6. All right, so put it in square brackets now. 7 there and 6 there. Now, obviously, this is to the power of minus 1. Let me just scribble over here. This is effectively x to the minus 3 to the power of minus 1. Integrate, raise the power by 1, divide by the new power. If I raise that by 1, it goes to 0. If I divide by 0, mathematicians go mental. So this is where the logarithms come in, the natural logarithms. So the integral of 1 over x minus 3 is the log of x minus 3, which I'm sure you are now aware of. This one here, that's effectively minus 3 divided times by x plus 2 to the minus 2. All right, so if I'm integrating this, raise the power by 1, it becomes minus 1, and then divide by the new power. So I'm doing minus 3 divided by minus 1, which is plus 3. So that gives me plus 3, and then I'm going to write the x plus 2 in brackets to the minus 1 back downstairs as a fraction. So are there any questions on that? Because that was quite a juicy bit. Please feel free to speak. Let's have a look at it again. These are what we got from doing our partial fraction bit correctly. From practice, you'll spot that that's a 1 over x, so that's log. Right, so whatever's underneath is just log of it. Of course, if that wasn't 1, if it was 2 over x minus 3, it would be 2 log x minus 3. Okay? And this one, you'll start to recognize that if there's something over a squared term, the squared term disappears, and you're just dividing this by minus 1. It's the same every time. Okay? It's just routine. And now you have to press buttons on this. So I'm going to invite you to do that now. I have done it. Right? I do have the numerical answer. So you are going to type in your calculator. Right. 7 minus 3 is 4. So you're going to type in log 4 plus 7 plus 2 is 9. So that's 3 over 9, which is a third. So there's your 7 part. And you're going to subtract your 6 part. 6 take away 3 is 3. Log 6. 6 plus 2 is 8. Plus 3 eighths. So you are going to press 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and equals 18 buttons. And then someone please type in the chat what the numerical answer is to 3 decimal places. Off you go. Come on, someone type it in the chat. Right, I have different to that. Pattern, I have different to that. Oh, I know why. I've written it down wrong here. I'm going to say this was my deliberate mistake for the day that none of you have spotted. Can you see my mistake there? 6 minus 3 is 3. I did that on purpose to see if anybody would pick up on it, and obviously you didn't. I've got 0.246. Can someone go, yeah, do you know what? I had the same. Awesome. Well, I'm counting out Bethan and everybody else who couldn't be bothered to say it. Right, so now your turn now, okay? I've shown you what to do. We're just going to do 4 of them, I think. So this is the next one I wanted to do. It's a differentiation one. The x squared term is already on the right. So hopefully you're already seeing in your mind 11 plus x minus x squared on the left equals a x minus 2 squared plus b, 1 of each, plus c, x plus 1. Hopefully you've already thought about what values of x you're putting in to eliminate these brackets, minus 1 and 2. The third value will be 0. Get your 3 fractions, and I want f dash of 0. So you're going to differentiate them. But my preference is to reciprocate them all and use a negative power, differentiate them, and then substitute x equals 0 into all of them. And I will give you 3 to 4 minutes, and then I'll go through it, okay? I'll tell you so you know the very, very final answer is not a whole number, but it's a pretty pleasing fraction. All right, off you go. 4 minutes. Got 90 seconds left, right? Well, if you need more time, you have to tell me. You know I always rush you. Anybody brave enough to type in what they think is the final answer? Nothing bad can happen. Has anybody got a final answer? I'm going to say what it is. Just let me know you've finished the question and I can go through it. I think I'll use this time to give a shout out to Hannah. Hi Hannah, you are watching this recorded. Hope you are well and enjoying this silence. Okay, I will go through it. Right, set it up. I know I got to chuck in 2 to eliminate them, -1 to eliminate them, and then 0 to get my b to it. Okay, so when x is 2, I've got 11 plus 2 is 13, -2 squared is 4, that's 9. That goes, 2 plus 1 is 3, so 9 equals 3c, c equals 3, happy with that. Now I chuck in -1, 11 minus 1 is 10, minus 1 squared is +1, so it's 11 minus 1, which is 9 again. That'll go, that'll go. So I have -1 minus 2 is -3, -3 squared is 9. So that's 9a, a equals 1. Happy with that. Chuck in x equals 0. I've just left with 11 there. Excuse me. -2 squared is 4. 4 a's, 4 ones are 4. They are 0. 1 times -2 is -2, so that's -2b. And 1c, which is +3. So I've got 4 plus 3, that's 7. Take it over, 11 minus 7 is 4, so -2b is 4, so b is -2. I'm hoping that's what you have. So we're left with 1 over x plus 1 minus 2 over x minus 2 plus 3 over x minus 2 squared. And we need to differentiate that now, right? We need to find f dash. So I'm just going to write it as x plus 1 to the -1 minus 2 x minus 2 to the -1 plus 3 x minus 2 to the -2, and then do power down and reduce the power by 1, and then I'm going to put it back into fraction form as well, right? So I'm going to try and do all of that in one step. So f dash of x equals, right, power down just makes it a minus, so it would be -1 over x plus 1 squared. The -1 has come down. I've reduced that to -2. I've just brought it back downstairs as a fraction and put the 2 there. The next one, power down. -1 times -2 is +2. And then that will go back downstairs again as a squared. And the last one, power down. -2 times +3 is -6. And that will go down then as x minus 2 all cubed. All right, so I'm hoping you're still with me. The last thing I then need to do, it asks me to find f dash of 0. So I'm sure we can do this in our head, right? There's -1 over 1 squared. That's 0. -1 over 1 squared is -1. Right. -2 squared is 4. So that's +2 over 4, which is +1/2. -2 cubed is -8. So that's -6 over -8. So it's +6 over 8. 6 over 8 is 3 over 4. -1 plus a half is -1/2, plus 3/4 equals 1/4. That was the answer. Someone please fib and say, yay, I had that. Please. Right, next one. Well done, Catherine, and thank you. Okay, so an integration one now, right? We should be plowing through these now, right? So within 4 minutes now, hopefully we'll have it. These are the wrong way round for my liking. So I'm going to rewrite it, x minus 1 on the left, x plus 3 squared on the right. The numerator is a bit juicier than normal, so take your time. Once you've got your 3 partial fractions, I want a definite integral between 10 and 3. Shall I give you some hints? Don't be afraid if the value of b comes out as 0 again. And don't forget, a over, I don't know, x plus b, when you integrate that, it's a log x plus b. All right, you're going to have to utilize that. So 4 minutes, off you go. Let's see where we are. And they want the answer to 2 decimal places this time. So I've got c equals 7. No. C equals -7. Not very common. I like a equals 2. C equals -7. Might be worth a double check. So I'm going to do that again. -3 squared is 9. 2 9s are 18. 18 minus 15 is 3. 3 plus 25 is 28. That goes. That goes. -3 minus 1 is -4c. 28 divided by -4 is -7. Yeah, that's right. Chuck in 0. That goes, that goes. That's 25. Right, 3 squared is 9. 9 A's, 9 2's are 18. Uh, 3 times minus 1 is minus 3b. And then minus 1c, minus 1 times minus 7 is plus 7. 18 plus 7 is 25. Which means b comes out as 0. And I'm sure on the day you would double check that, but I did give you the hint that I think that's what's going to happen. So I'm left with f of x equals, okay, 2 over x minus 1. The b term has disappeared, minus 7 over x plus 3 squared. That was the 4 marks for getting the partial fractions. Now they want us to integrate it. So I'm going to draw square brackets and put 10 and 3 there because we have limits. The integral of this, you'll start to obviously just recognize it. It's going to be a log. If it was 1 over x minus 1, it would just be log of x minus 1, but it's 2 over x minus 1. So it's 2 log x minus 1. Think of this as being written minus 7 brackets x plus 3 to the minus 2. Raise that power by 1, goes to minus 1, and divide it by the new power. Minus 7 over minus 1 is plus 7 over x plus 3. Everybody with me still? I'm going to assume a yes. And now you're going to press some buttons on your calculator. All right, it does say this is 2 decimal places, so it's not going to be a nice answer like the last one. So you're going to do 2 log, right, 10 minus 1 is 9, plus 7 over 13, because 10 plus 3 is 13. And then you're going to subtract 2 log 3 minus 1 is 2, plus 7 over 6. So I invite you to do that, assuming you agree with what I've done so far, and then someone please type in the chat the answer correct to 2 decimal places. Right, I'm sure you can all see what Catherine has put in the chat there, and I have to agree. I got exactly the same, and it'd be too coincidental for us to get the same answer and it not be correct. So very well done, Catherine. That is correct, right? Now for 7 marks, and let's ignore the fact that you're not sitting in an exam, that's irrelevant. For 7 marks, you've got to think, do you know what? I can do this question every time. I don't have to think outside the box. I just practice the routine. I know how to get A, B, and C. And as long as you're confident with your differentiating and you're integrating, careful with your negatives, and you press the right bits of plastic, this is 7 marks in the bag each time. Okay? Now, there's 3 more on the sheet, on the packet, right? So I'm going to leave it up to you. So whoever answers this, we're going to go with it. I want you to do at least 2 of them independently for me and upload it so I can mark them. I need to start having a bank of evidence of stuff you're doing on your own. We can either do all 3 on your own, do it right now and upload it within the next like half hour for me, take a photo, whatever. or I'll do this last one with you, and then you just do the other two. Someone make a call now. Are you going to do 3 on your own and send them to me, or I do 1 more and you do 2 on your own and send them to me? Griff, your head boy, make a call, please. Do you want to do 3 or 2?
I don't care, to be honest.
Right. I'm flipping a coin then. Heads, I do this one, and you just submit 2 of them. Tails, you're doing all 3 of them. It's tails. You're doing all 3 of them, okay? Right, let me just give you a hint on this first one. First of all, they're the wrong way around, so rewrite these so the x squared is on the right. Get your partial fractions, easy peasy. Differentiate it, it asks for f dash of x. And then the only thing that's different on this one is this bit of vocabulary. Verify that it has a stationary value when x equals 2. Now, I'm sure you remember back in year 12 doing maximum, minimum, stationary values. When you differentiate something, you find its gradient, and therefore the gradient is 0 at the stationary value. So you're going to differentiate this, get your 3 terms. You're going to sub in x equals 2, and then the answer will come out as 0. Right? So I'll say that again. Get your 3 partial fractions, differentiate them, sub in the value x equals 2, and because that is a stationary value, it will then give a final answer of 0. Right, the other 2 then, that's set up correctly for me. Just work out a, b, and c, and then a definite integral between 7 and 5 to 3 decimal places. Right, so you're confident you can do that now. And then the last one, this is off last year's paper. And the reason I know that is because it says sufficient working must be shown to demonstrate the mathematical method employed. Because on your newfangled super duper calculators, there's probably a way it'll do this on its own, but you have to show all the working out, right? Look how easy it is. Look at the numerator, it's just 9. So split it up, it's all set up nicely for us. And then it's an indefinite integral. So this is the one I was on about at the start. If you don't put plus c right at the end down here somewhere, you will lose a mark. Okay. Now I thoroughly recommend you do 3 of them. You do the 3 of them right now. Okay. Please take a photo of them and email it or upload it to Google Classroom. By whatever means you can do that, so I can mark them off, and then in my spreadsheet I can go, yeah, you all came to the lesson and you did the work and it was correct, and that's great. Does anybody have any queries or questions about that? Bouncy told me to say hello, and he will see you Friday for his lesson. But if there's nothing from you, I bid thee farewell. And I got another live lesson at midday. So I'm here right in front of my screen now for the next hour and 10 minutes. So you can email, you can chat on Google Classroom if you have any questions. Please get all 3 sent to me by my lunchtime lesson. All right, but if that's it, I'm going to say ta-ta and stop recording, right? So take it easy, everyone. Hope that was okay. Any questions, get in touch. You're welcome, Bethan. Bye, Catherine. Bye, Megs. Bye, Griff. Bye, Sam. Bye, Fletch. And everybody else. All right, take it easy. I'm stopping recording. Bye.